Today we get to have a lot of fun with an entire junk drawer full of tips that we ran across while setting up this single part. We're going to cover things like how to probe the unprobable. We're also going to show you some of my favorite tools, and I'm going to give you my top secret, best design secret, show you how I kind of spruce up my parts. So stick around. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, so here's a situation that comes up fairly often when we try and use a probe or an edge finder to pick up a part. I've got here a little tiny part that's made out of a great big piece of aluminum. And if we try and run the second operation on this part, we just flip it over and put it in the vise. Before we can run op 20, the second part, we need to set the 0. And on this particular part, our 0 is the left edge and the back edge of this part along those two surfaces. If we come down with our probe and try and probe that surface though, we've got an issue. The probe is going to shank out on that white ceramic shank. It works when the ruby tip makes contact. So how do we solve this problem? So here is how we probe the unprobable. We don't. What we're going to do is use a surrogate part. In this case, a 1, 2, 3 block, or a 25, 50, 75 block for my metric friends. We're going to load that block up into the vise. We can now probe the side of our block and use that as our work offset. It's going to put our work offset in the exact same spot it would have been had we probed our real part. So use a surrogate part that doesn't have the offending feature that blocks our probe instead. While we were setting up this part, we came across a few other topics that we thought were pretty cool and we wanted to share them with you. One of them had to do with the Allen wrenches that I used when tightening up the part stops in my vise. So here are my Allen wrenches. Pretty basic, but I wanted to show you this guy. Now, hopefully, if you've been a machinist for any amount of time at all, you've found yourself your perfect cheater bar, your perfect pipe. A pretty simple thing, but I realized that this is probably one of my favorite tools in my entire toolbox. When I'm loosening up bolts or tightening them, this is a palm saver. It keeps me from bruising my hands. You want to find a bar that is as tight as it can go, but still fits over your largest Allen wrenches, your 10 millimeter or your 3/8 Allen wrench. Just one of my favorite all-time tools. Make sure you've got one in your box. And if you're picking out a set of Allen wrenches for the first time, make sure you get a set that has the little ball ends on them. These really help when you're doing things like changing out the jaws in a vise. They can just reach in at an angle and still allow you to turn those bolts. What I've used more recently are these guys. I've switched to these because they're color-coded. Not a big difference, but I just love these guys because I know that my 5/32 is that little red one right there, and I use that one all the time. So, cheater bar, gotta have one. Ball ends in your Allens, gotta have them. What I've moved to more recently, is a new set because there is something I don't quite like about these Allen wrenches, and it's that every time I go to use them, I have to move these guys out of the way, move those 3 Allen wrenches out of the way before I can grab this one that I'd like to use. And while this is a small issue, a first world problem, I saw a post on a forum online and with another set of Allen wrenches, and I had to get them. So this is one I bought more recently. It's these guys from WIA. And this is what makes these Allen wrenches special. It's that when you want to pull out a wrench, all you've got to do is turn them. So these wrenches are spectacular, not because of the wrenches, but because of the case. So I just thought it was really cool and thought I would pass that along. So I've started using these more recently. Now, talking about Allen wrenches seems pretty trivial, but it's not for machinists, not when you're on the machine for a lot of your day. Things like cheater bars really help, especially when we're using something as much as we use an Allen wrench. We all become very comfortable with the tools that are in our toolbox. So be sure to comment. Tell us what tools you use every day that make a difference, that make your life better. Those are the tools that we all want to buy. We want to see what's in your toolbox. So this was one little tip, but we were saving the best for last. In the part that we were making, this guy right here, we wanted to show how to probe, right, that flange part. So I had to make a part, so I made this guy. But I wanted to make it cool looking, right? I spent 20 minutes, setting up the part and programming it, a couple holes and walking the perimeter. Generic, boring part. Typically on a part like this, you would just walk around the outside edge and create a uniform chamfer, 30 thousandths of an inch, 0.75 millimeter. You just walk around that edge and it's got a boring chamfer. But the chamfer on a part is like the icing on a cake. You can be creative and it really affects the final look of the part. If you look at this guy, it's a kind of a cool looking part, but there's nothing fancy about it. I kind of cheat on almost all the parts that I make to make them fancy. You can see this guy right here. It looks amazing, right? What an amazing, cool, shiny looking part. But one of the key features of this part is this cool swarf cut around the outside edge, right? It looks like a 5-axis cut. It must have been a 3D surface or something, right? The tool must have been going up and down around those corners. But that's not the case. My dirty secret is I just give my chamfers their own unique contour, their own unique cutter path, different than the contour used to create the outer surfaces. So take a look at this CAD file, and you can see that my end mill walks around the outside of the part, and then my chamfer tool is walking across a different profile that I've created. And if we watch the part run, we can see that our chamfer tool is not moving up or down at all in the Z. It's simply walking around the outside, and it cuts in the XY a little deeper in some spots than others because I've given it its own profile in the CAM system. So this is my secret on how to make cool, sexy looking demo parts. You'll realize that it's actually pretty basic. It's pretty simple. So that's all we've got for you today. I hope you picked something up, and we'll see you next time. Thanks for watching this Haas Tip of the Day. I can't believe we're going to show you this, but it's cool. I had fun with it. This is how you spin an Allen wrench on your finger, okay? So safety glasses, face masks, go try it in the parking lot where no one else is looking. But if you're going to try and spin an Allen wrench on your finger, here's the key. Find the longest Allen wrench you've got in your set, not a short one. The shorter the Allen wrench, the harder it is to spin on your finger. You're going to take your Allen wrench, you're going to have it face away from you, and when you spin it, you're going to want your finger to climb up the long end of the Allen wrench. So you face it away and you spin. So you can practice that, make sure you're wearing your safety glasses, and you can go from there. And that's how you spin an Allen wrench on your finger.